Today we're still going to talk about algebraic expressions, so it's going to be very similar to yesterday. We're going to go ahead and just do a second day of it to hopefully help this set in your mind a little bit more. So let's review from yesterday. It asks us here to identify the terms. That means find the terms and the like terms here in this expression. Is there anything else that you guys can see in the x family? Taylor, what do you see?
6x.
Not 6x, negative 6x. Good job. So let's underline that too. Is there anything else there in the original problem that's in the x family? Nope, that's it. Let's go on to something different. I see a 10 here. Do you see anything else that would be in the constant family, the number that stands by itself? Negative 20. Now the last one that you'll see here is 5y. Are there any other terms similar to 5y? Nope, it's by itself, so we're just going to leave it alone. So now let's go ahead and separate it out. Let's talk about the terms that we see there. What's the first one?
Negative 5x.
The next one?
Negative 10.
10. What's the next one?
Negative 6x.
Good job. The next one?
Positive 5.
And the final one?
Negative 20.
Okay, so remember, when we talked about it yesterday, the term is just the different parts of the expression that are being added or subtracted together. Now it's asking us to find the like terms. Nikki, what are my like terms in this problem?
The things that are alike.
You're right, it's the things that are alike. Can you tell me which ones are it for problem A?
Negative 5x and negative 6x.
Good job. Are there any more?
Yes. Positive 10 and negative 20.
Very good job. Okay, so all she was doing is finding the ones that are in the families together. What about 5y? Should I put that down there?
No.
Why not?
Because they all have no like.
There's nothing else that's like it, so it's not a like term. Next up is the coefficients. I want you guys to flip to your notes that we did from yesterday. There were a lot of vocab terms, and I want you to read to me, what is a coefficient, class?
The number part of a variable term.
The number part of a variable term. Remember, a variable is a letter, okay? So you can see right here, this has a letter in it, this has a letter in it, and this has a letter in it. I don't want to know what the letter part is, I just want to know the number. So guys, what are my coefficients? What are the numbers?
Negative 5, negative 6, and 5.
Okay, now listen, I heard 10. 10 is not 1 because that's not attached to a variable, okay? The coefficient is only the number part of a variable term. So we had negative 5, then I heard negative 6, and the final one was?
5.
Regular old 5. A constant. That was another vocab word that we learned. Do you guys remember what a constant is?
A number that stands alone.
A number that stands alone. That means it's not attached to any letters. What are my two numbers that stand alone?
Negative 20.
Positive 10 and negative 20. Good job, guys. All right, problem B looks very similar to that. We've got to underline and circle. Cameron, what should I underline and circle in my original problem?
4b and 5. Positive 5b
Good job.
and 5.
And what should I circle? Very good. Those are my constants, so we're going to go ahead and circle those too. Madison, what are my terms?
4b, negative 19, and 5b.
Very good. Harmony, what are my like terms?
4b and 5b.
Good job. They're a part of the B family. Are there any other like terms in my original problem?
Yes.
Harmony, what are they?
Negative 24 and 19.
Good job. Those are my constants, or those are the numbers that stand alone. They're alike because they are both constants. Next up, a coefficient. Remind me again, guys, what's a coefficient? The number part of the variable term. Who wants to help me with that? Ayana. Very good job. 4 and 5, okay? And she did not say 4b. She didn't say 5b. She left the variable part alone because this is just the number part. Excellent job. Next up, Alexis, what are my constants?
4 and 19.
Very good. Okay, so this is how we identify different parts of what that expression is. For number 2, this is asking us something totally different. Now, last night on the homework, some people kind of mixed up their instructions. When this says to simplify the expression, that means to make it more simple. So we're going to combine the terms that we can that are alike. Let's underline things that are alike. What are the first two that we see that are alike, class?
3, 4, 1 half, negative 1 half.
And negative 1/2 y. What else is similar or like terms?
12 and negative 6.
Positive 12 and negative 6. All right, so sometimes people get scared whenever they see fractions, but we don't have to be scared. We're just going to combine those like terms, but we do have to do a little bit of extra work. So we've got 3/4 y minus 1/2 y. Do I need the same denominator? Yes. What should it be?
4.
A 4. So this one's going to stay as 3/4, and this one, how do I get that 2 to turn into a 4?
You gotta do a 2.
You multiply it times 2, and then we'll multiply this one times 2. What does that equal? 2. So now we are working with this, 3/4 y minus 2/4 y.
1/4 y.
1/4 y. And should it be positive or negative? It is a positive, okay, because if you look, the 3/4 was bigger than the negative 2/4 because we were subtracting it. So we've got 1/4 y. Am I done? No. If you notice, I still have plus 12 minus 6. What is plus 12 minus 6? 6, okay? Because you can see those are different signs. We subtract them and take the sign of the larger number. So is my 6 positive or negative?
Positive.
Positive. Here's what a lot of people did yesterday on their homework. They just left it looking like this. But you've got to put it in the positive because that tells me it's 1/4 y plus 6. Now, does that technically equal 6 1/4 y?
No,
Why not?
because you can't add a y to something.
You cannot add these if they're not like terms, okay? This is a part of the y family. This is a part of the constant family. So you cannot smush them together and try to add them because they're not like terms. Good job. Let's go on to the next one. Haley, what should I underline? What else is in the y family? Negative 5y. Now what should I do? Excellent. Circle the 4z and circle the 9z. Now I've got some terms here. I want to go ahead and add them together. Let's do the y family first. Sierra, negative 3y plus negative 5y. Okay, and keep the sign. Is it positive or negative? Negative, okay? Because you can see right here, same sign, add the numbers, keep the sign. That's how we get negative 8y. Now let's go on. 4z plus 9z equals what? 13z. And am I adding 13z or subtracting it? You're adding. Simply because we know that that's a positive, we are going to add it together. All right, Brody is going to try problem C for us. Are there any like terms?
Yes.
Brody, what are they?
2.5x plus 4.3.
Excellent. So I'm just going to underline them because they are like terms. And then that negative 5 or minus 5 is just kind of hanging out there for now, okay? What should I do with the 2.5 and 4.3? Add them together. If you can do it in your head, you are welcome to do it in your head. If you do better with doing it on the side, you can go ahead and do it on the side. Brody, what do you get when you add those together?
6.8.
Okay, so now read us what your answer is.
6.8 x plus negative 5.
Okay, what does plus negative 5 mean? Who always wins out of a plus negative 5?
A negative.
A negative, okay? So all you have to do here is just bring that down, minus 5. Can I combine those to turn this into a 1.8x? No, why not?
Because they're different families.
They're in different families, okay? This is the x family and this is the constant family. So do not try to mix them together, okay? Great job. Thank you, Brody. All right, we've got a modeling real life problem here. Each person in a group buys an evening ticket, a medium drink, and a large popcorn. How much does a group of 5 people pay? So the first thing is they've got to buy an evening ticket. How much is an evening ticket?
$7.50.
All right, $7.50. Okay, now we know that 5 people are going to be coming, but let's say we didn't know. That is $7.50 per person. So we're going to call one person an X, okay? Now, that person is also going to go to the movies and buy a medium drink. How much is a medium drink?
$2.75.
All right, so plus $2.75. Once again, that person, we're going to call him an X because he's buying that. He's going to buy something else. What else does he buy?
A large
How much is a large popcorn? A large one is how much?
$4.
$4, okay? $4. 4. Just for the sake of it looking like the rest of these, I'm going to put 4.00, and that's for one person. All right, finding some like terms here. This is the X family. Is there anything else in the X family?
All of the numbers.
All of them are in the X family. So let's go ahead and add those up together. Go ahead on the side, and I want you guys to add it on your own. Remember to line up your decimal points. Okay, guys, when you added all that together, what'd you get?
$14.15.
Okay, $14.25. Now, it's a part of the X family, so I'm going to keep the X there. As I go back up here, though, to look at my final question, it says, how much does a group of 5 people pay? So this X was counting for one person. For one person to go to the movies, get a ticket, a drink, and a large popcorn, it was $14.25. But I don't want to know it for one person. I want to know it for how many people. So what should I do with that X? Times it by 5. So we're going to have 14.25 times 5. All right, once again, you can do the work over here on the side. How much did that group pay?
$71.25.
$71.25. The X disappeared because we plugged in the 5 right there, because the 5 represented how many people. Remember, the X was representing how many people went. So $71.25 for all the people. For this next one, it asks us which one doesn't belong. So we've got to go through these 4 different options to try to figure out how to figure out which one doesn't belong. So this is a constant, and this is a constant. And then that 3x is all by itself. All right? So what should I put first, my variable term or my constant?
Your variable term.
We always put the variable term first. So let's just go ahead and rewrite it. That's a 3x. Now let's focus on this right here. Same sign or different sign?
Different sign.
Different sign. Subtract and take. What do you get? 2. A positive or a negative?
Positive.
Positive 2. So that is 3x plus 2. Okay, so we know that one's 3x plus 2. Let's go to the next one. What should I underline?
The 2x and the 5x.
Let's underline 5x and negative 2x, because those are like terms. And then the negative 10 is going to be by itself. So let's focus on my X family. What's 5x minus 2x?
3x.
3x is correct. And what do I do with my minus 10? Just bring it over. Do those equal each other? No, they're 2 separate things. So now I want you guys to do 3 and 4 on your own to figure out which one of those doesn't belong. All right, I saw a lot of right answers as I went around. This next one, we had a positive 9 and a negative 7. This 3x was here all by itself, so I'm just going to bring the 3x over here. Let's focus on this. Same sign or different sign? Different sign. Subtract and take. What do you get? Negative 2 or positive 2? Positive 2. Final one we've got here, 5x and negative 2x, negative 4, and positive 6. Let's do our x family first. What's 5x minus 2x?
Positive 3x.
Positive 3x. And then what is negative 4 plus 6?
Negative 2. No, just 2.
Okay, you got to take the sign of the larger number, which was positive. So it should be a plus 2, okay? Of all of those guys, which one does not belong?
2.
Number 2 does not belong, okay? I hope that helped you to understand 3.1 just a little bit better.